Alright, so in this video, we are going to tackle a slightly more advanced problem involving equilibrium. As of now, everybody should know what equilibrium is, which basically means that the net force on a system, on an object, okay, or a system is equal to zero. Okay, so that's the definition of equilibrium. And in this problem, what we have is we have a 10 kg block that is connected by two strings. And the first string makes an angle of 45, the other one makes an angle of 37. And our goal is to calculate the tensions in the two strings. So we want to know what the tension 1 is. We want to know what tension 2 is. Okay, and what we know is that the entire system is at rest. So we can therefore use the concept of equilibrium to figure out these tensions. Right, so what we'll do is first thing we'll draw our free body diagram. So again, what I suggest you do is pause the video, uh, okay, draw a circle, and then draw forces that you think um, are exerted on this block. Okay, and once we do that, then you can come back and we'll continue. Okay, so I'm assuming that you've drawn your forces. Let's see if the forces match. Okay, so the first one is going to be 10 times 9.8, which is the weight of the object. If you have this, give yourself a pat on the back. The second one is going to be tension 1. And what I'm also going to do is draw a little axis here and label this angle. Okay, in this case, this angle just from basic geometry is going to be 37 degrees. Okay, and now we have a second force, the third force, which is T2, and T2 makes an angle of 45 degrees with the horizontal as shown. All right, so these are our three forces, and what we want to do is apply the idea of equilibrium. Okay, um, now you see that these forces are not all pointing in the same direction. So we have to use vector algebra to figure out how to go about solving them. So the first thing we'll do is draw the components for each of the forces. Okay, and so if you look at T1, the component of T1 in the direction or along the x direction would be a vector pointing here. The component of T1 along the y direction would be a vector pointing in this direction. Okay, and from vector algebra, we know that the horizontal component is going to be T1 times cosine of 37, and the vertical component, is going to be T2, not T2, T1 times sine of 37. All right, so now we have the components of T1. We'll do the same thing for T2. So go ahead and draw first the arrows representing the components of T2 and then write the components of T2. So pause the video here, complete that, and then come back. All right, so I'm assuming that you've done that. I'm going to draw my component here, which is going to be T2 times cosine of 45. And then we'll draw my other component, which is going to be equal to T2 times sine of 45. Okay, now please understand that the directions of the components are very important because based on the directions you will have appropriate signs. Okay, so now there's a lot of stuff going on in this picture. Just focus on the components. Okay, especially the components of T1 and T2. You can ignore T1 and T2 at this point. Right, so let's go ahead and write down our equations. So first, I will write down an equation along the x direction. Okay, since the system is in equilibrium, we know that summation of all the forces along the x direction, okay, no vector sign here, along the x direction, the summation of all the forces will be 0. So what do? Let's look at the x forces. We have T1 cosine 37 pointing to the right. We have T2 cosine 45 pointing to the left. And those are the only two forces along the x direction. So we can write our equation as T1 cosine of 37 minus T2 cosine of 45 is equal to 0. Okay, so this is equation 1. Now, we can write a similar equation along the y direction. Okay, so let's write a summation of all the forces along the y are also equal to 0. So at this point, pause, write what you think would be an appropriate equation along the y direction, and then come back. All right, so I'm assuming that you paused, you wrote your equation, and let's see if the equations match. Okay, so along the y direction, you have t2 sine 45 pointing up, t1 sine 37 pointing up, and then you have 10 times 9.8 pointing down. Okay, so once again, since the sum of all the forces will be 0, what we can do is we can add up all the forces that are pointing up. So it'll be t1 sine of 37 plus t2 sine of 37 is equal to 98, or we could have written this as minus 98, and all this is equal to 0, just to stay true to the theme that the net forces are 0. Okay, now at this point we have two equations. Okay, so I'm just going to rewrite equation 1 after calculating cosine 37 and cosine 45. Okay, so we know that cosine 37 is about 0.8, so I'm going to write t1 times 0.8 minus t2 times 0.707. Okay, all this is equal to 0, and we can rewrite equation 2 as t1 times sine 37, which happens to be around 0.6, plus t2 times, oh, I do have a mistake up here. So this should have been t2 sine 45. Oh, my bad. So t2 times 0.707 again, and we'll write all this is equal to 98. So I'm just rewriting the two equations. Now, basically, we have two equations and we're trying to solve them for the two unknowns. So we could choose to eliminate either T1 or T2. Okay, so in this case, I'm just choosing to eliminate T1 from my equation. So from the first equation, we can rewrite T1 as 0.707 times T2 all over zero point 0.8. Okay, and you can calculate this, but I'm just going to move on to the next line and then you guys can finish the calculations. Okay, so now we can rewrite this as uh, so we said T1. Okay, so in the second equation we can replace T1 in it. So T1 was 0.707 times T2 divided by zero point 0.8. Okay, we'll multiply this by 0.6 and then plus T2 times 0.707. All this is equal to 98. Okay, so at this point, go ahead and calculate. So you can rewrite the first term as T2 times 0.707 times zero point 0.6 divided by zero point 0.8, and you should end up with, let's go ahead and calculate it. So you have 0.707 times 0 0.6 and then divide this by 0 0.8 and you get 0.53. Okay, I'm just going to leave it as 0.53025, so I'll leave it as 0.53 and then plus T2 times 0.707, which is 98. Okay, so now we can combine the two and we get T2 times 1.237, okay, is equal to 98, and then we can solve for T2 as 98 divided by 1.237, and this is about 79.22 newtons. Okay, once we have T2, we can use the equation above for T1, and we can write T1 as 0.707 times 79.22 divided by 0 0.8, which becomes about 70 newtons. Okay, so if you think about this problem, we started with the picture itself. We drew our free body diagrams, set the x and the y equations equal to 0, and then proceeded to solve. Okay, so make sure you understand all the steps, because if you do, I want you to go ahead and do this problem and you guys can check the answers with each other. Give yourself a few minutes to do this. Okay, let's make this 53 degrees. Let's make this 30 degrees, and let's make this a 20 kg block. And your goal is going to be calculating tensions T1 and T2. Okay, the first attempt should be try to do this without looking back in your notes and see if you figure all this out, and then check with each other for the answer. I will, at some point, I might even post it online or something to give you the answer. Okay, otherwise, just check with each other. All right, that's it for this video.